Hi everyone, this is our second lesson. This lesson we're going to learn about vectors and how to break them into their components. First of all, let's identify what is a vector. Let's see what a vector is. A vector is an arrow which has a magnitude, length, and direction. As long as I maintain both of them, the arrow doesn't change. For example, the vector doesn't change. Suppose this is my vector. As long as I move it like this, it's the same vector. Once I turn it, or once I multiply it by its length, it's another vector. So as long as I maintain its magnitude, length, and angle, direction, it's the same vector. Now let's see what I can do with this vector. I want to break it into its components. What does it mean? Suppose I have a ball right here and I pull it with a force of 20. It doesn't matter what 20 means. It means that it's less than 40. 40 is stronger, 20 is weaker. And with an angle of 30 degrees. What I expect that will happen, I expect the ball will move this way, which it probably will. I want to do something else. I want to break this vector into its component. What does it mean? Suppose my name is Danny. Danny pulls it like this. Instead of Danny, I want two people to pull this ball and the ball will feel exactly the same. What should I do? One person should pull it to the right, and the other person should pull it upwards instead of this one. So instead of pulling it here, I can pull it both simultaneously here and there, and the ball will feel exactly the same as if it was pulled by 20 in this angle. So the question is, how do I find this component? This is called the components of this vector. How do I find them? The idea is, let's see where it comes from. If we close a triangle, a right triangle here, we have the x component and the y component. Now we learned the right triangle, and we know that if we want the x and the 20 is the hypotenuse, x the adjacent side, it's beside, next to the 30, this is the hypotenuse. So I remind you, sine alpha is opposite over hypotenuse. Cosine alpha is adjacent over hypotenuse. And tangent alpha is opposite over adjacent. So suppose I want the x. X is the adjacent and I have the hypotenuse. Adj hip is the cosine. So cosine 30 equals to x over 20. And if we multiply by 20, we get x equals to 20 times cosine 30. Let's do the math. 20 times cosine 30, it's 17.32. Suppose I want the y component. This component is exactly the same as this one, because if I close it here, it's like a rectangle. This and this is the same. If I want the y, it's opposite the angle, opposite the 30. So I want the opposite, up, and I have the hypotenuse. Up, hip, who corresponds? The sine. So sine 30 equals to y over hip. Opposite side over the hypotenuse. So y equals to 20 times sine 30. If you go to the calculator, it's a known angle. The sine is half. So 20 times half is 10. So what's our conclusion? Instead of pulling the ball with a force of 20 in the magnitude of 30 degrees, we can instead, I cancel it, I can pull it here to the right with a force of 17.32 and upwards with a force of 10. So if I do this and this simultaneously, the ball will feel exactly the same as if someone pulled it with 20 in this direction. So what's our conclusion now? We don't have to do this all the time to break it with right triangles. We can conclude it like this. Let's write it. Every time I have a vector, let's draw it. Every time I have a vector, let's say the length is f and the angle is alpha, and I want to break it into its components, to the x component and the y component. The trick is not to draw again the triangle, because it takes time. The idea is that the arrow, the vector, next to the angle, always get the cosine. Let's write it. The vector component beside the angle always gets the cosine. What does it mean? It means that if I want to know what this vector is, I do f times cosine alpha. And the other vector always gets the sine. So this one will be f times sine alpha. This is the idea. I'll show you another example. Suppose this is my vector f and this is alpha. I want to break this vector into its components. So the components will be upwards and left. Which vector is beside the alpha, next to the alpha? This one. So it will get the cosine. Always the vector beside the angle gets the cosine. So the y component will be f cosine alpha, and this component will be f sine alpha. The other component gets the sine. The vector component beside always gets the cosine. Okay, let's do a few examples. Let's start with one. Okay, let's start with this one. Let's say I pull a ball here with a force of 30 with an angle of 40 degrees. I want to break this force into two components. The components will be naturally to the right and downwards here. Instead of this one, this vector, I want these two vectors, components. So I want the value, the length, the magnitude, because I know the direction. The direction is right and downwards, but I need the magnitude, the length. So how do I talk to myself? The vector, the component beside the angle gets the cosine. This one, this vector, is beside the 40, beside the angle, so it will get the cosine. So it will be 30 cosine 40. And the other one, naturally, we will get the sine. 30 sine 40. We go to the calculator and we do 30 cosine 40, 30 cosine 40, 22.98, and 30 sine 40, 19.28. What does it mean? It means that instead of pulling the ball with a force of 30 in this direction, 40 degrees like this, if I pull it 22.98 to the right and simultaneously 19.28 downwards, it will feel as if someone pulled it with this force in this way. Another example. Let's try this one. Let's say this force is 40 and the angle is 20 degrees. And I want to break it into its components. So first I identify the components. Naturally, one will go left, one will go downwards. I want to find them. How do I find them? This vector component is beside the angle, it will get the cosine. So it will be 40 cosine 20. And the other one, 40 sine 20, will get the sine. And again to the calculator, 40 cosine 20, 37.587, let's say 59, and 40 sine 20, 13.68. So if I pull this ball, imagine there's a ball here, 13.68 to the left and 37.59 downwards, it will react exactly the same as if someone pulled it 40 with 40 force of 40 in this direction. One more. So example 3. Let's say I have this force, which is 5, and this angle, which is 60 degrees. I want to break it into its components. Again, I choose the right components. Naturally, one will go upwards, one will go left. I want to find the magnitude of these components. This one will get the cosine. Why? Because it's next to the angle. So it will be 5 cosine 60. And the other one will get the sine. 5 sine 60. And I go to the calculator. This is also a known angle, it's half. 5 times half is 2.5. You can do it in the calculator. And this one is 5 sine 60 is 4.33. So again, if I pull it 2.5 upwards, 4.33 left, it will feel exactly the same as if someone pulled it with a force of 5 in this direction. Okay, another example. Let's try a symmetric example. So 4. Let's try this force. Let's say it's 8. And this angle is 45 degrees. We can know intuitively that it's a symmetric problem. The components should be the same. Why? Because the vector is exactly in the middle here of this, in the middle, okay? So when I break it into components, to the x component and the y component, none of them should be, this one shouldn't be more than that one, or that one should be more than this one. Why? Because the ball must go symmetrically exactly in the middle. So I expect the size or the magnitude of this component and this component to be exactly the same. Let's see. This component is next to the angle, it gets the cosine. So this is 8 cosine 45. This one will get naturally the sine. Let's see. So if I do 8 cosine 45, it will be 5.65665, let's say 566. And if I do 8 sine 45, I get exactly the same. So it's okay, yes, because this one and this one are the same. Naturally, the ball will go exactly in the middle, like we expected it to do. Okay, one more. Now, let's try with letters, not with calculator. Okay, let's say this is F and this is alpha. and I want the components. Not always I use the calculator, sometimes I just write it with the letters in the exercise. Okay, again I break it into its components. One of them is this direction and the other is that direction. Which one will get the cosine? The cosine will be next, the vector next to the angle. So if this is my angle, this one will get the cosine. So it's f cosine alpha, f sine alpha. So instead of pulling it with f in this direction, if I pull it with this force and this force in these directions, the ball, which is here somewhere, will feel exactly the same. These two are, instead of this one, they're not with it, we wipe it out, we cancel it, and we say instead of this one, we use the components. So this is our lesson about breaking vectors into its components. The other lesson, the next lesson, in lesson 3, we'll learn how to add components, how to make these two into one, the other way around. Okay.